Okay, let us start this thing. So first problem we can discuss. So very easy problem. Can anyone solve this one? I'll start with the easy problem, then we'll discuss some difficult problem. So in this session we'll be discussing few concepts: node analysis, mesh analysis, superposition principle, Thevenin theorem, Norton theorem, and some other things. Okay, so everything we'll try to consider here. So can you find this circuit, the current through this 4 ohm resistance? This is the question. So how to find this one? Okay, so this is very easy problem. In many ways you can solve it. So for this problem, if you use node analysis, that could be done. Okay. So if you use node analysis, this node, one node you need to consider as a ground node, and this node potential, if you consider it is V1, then there you can apply KCL at this node. So if you apply KCL, Kirchhoff's current law, so current through this side, that will be B minus 24 exactly. It is 24. This node potential is 24 upon this resistance 4. Okay. This is the current going from V1 through this 24 volt. Okay. And this is the incoming current 2 ampere. So this is that I can consider it is a -1. Outgoing I am considering positive. Incoming I will consider negative. Okay. And this outgoing plus B1 minus 0, because there is no source, by 4, that is equals to 0. Am I correct? So can you solve for V1? So this is exactly V1. Can you find V1? Anyone please? What is V1? That easily we can find out this V1. What is this? So this 4 we can multiply here. Okay, we can simplify this circuit this side. So this is your B1 minus 24 minus 8 plus V1, that will be equals to 0. That means 2V1 equals to 32. So what is V1? 32 upon 2 means 16 volt. Yes, you are correct. The voltage is 16 volt. So what is the current? Now question is that what is the current through this 4 ohm resistance? That is now simple. So this VI, the current through the 4 ohm, is simply V1 upon 4. Means 16 upon 4 means 4 ampere. Is it okay? Good. So this is node analysis. Now can you use source conversion for the same problem? Can you check that the same thing could be solved very easily using source conversion? That also I will try to show you. Okay. So let me consider this one again. I repeat. Same problem I want to solve using source conversion. How quickly we can solve it? I think you understand about the source conversion. Okay. So can you solve this thing? Yes, good. So what we'll do, this voltage source and resistance, that we can convert it to current source and parallel resistance. That is the important thing. Then rest circuit will join. So first let me know what is the current value. What is the current value? This 24 upon 4. So this value will be 24 is the voltage level and 4 is the resistance. So it is nothing but 6 ampere. Okay. And this resistance 4 ohm will be coming here. Means we are going to convert this voltage source to current source parallel resistance. And then we will connect this one and this resistance. This is your 2 ampere upward, this is your 4 ohm. This current we want to find out, right? So now what we can do, this 6 ampere and 2 ampere, these two we can combine together because they are connected parallelly. So we can simplify it to one single current source. That value will be 6 plus 2, that is your 8 ampere. Is it okay? And then this 4 ohm, this one I am writing here, and then I will add this one, the last element 4 ohm again. There we need to find out the current. And you can see this current is very easy to find out. What is that? You can use current divider rule. So total current is coming here 8 ampere. So both branches are 4 ohm. They are equally divided. So this I will be simply half of this 8. 8 by 2 is a 4 ampere. So is it easy to follow? Okay. So these are two methods you have considered. You may also consider, because they are having two sources, one is independent voltage source, other one is independent current source, right? So can you use superposition principle? Okay, can you use superposition principle? So here, just 1 minute. So same circuit we want to solve using superposition principle. So what is this? According to this principle, we need to consider one source at a time. So if I consider that 20 volt source is acting alone, and second time we will consider that this 2 ampere current source is acting alone. Is it okay? Now if 20 volt source is acting alone, that means we need to remove the current source, and current source should be open circuited. If you want to remove the independent current source, that source will be removed, means will be open circuited. And if you want to replace voltage source, that should be shorted. So here what we will consider? We will consider this voltage source as it is, this is your 20 volt, and this resistance is 4 ohm, but we want to remove this current source, so this is made open. Okay, now we want to use this one. This is the 4 ohm. So what is the current? That current I will consider I1. So I1 is the current when only 20 volt source is acting alone. Okay, so can you find I1? So what is the I1? This is total voltage 24 upon total resistance. What is this? 4 plus 4 is 8. So this is equals to 3 ampere. Is it correct? So can you find the current I2 when 2 ampere current is acting alone? Good. So when 2 ampere current is acting alone, so that means what I do? I have to consider this current source as it is. Only thing is that I need to remove the independent voltage source. So this voltage source should be shorted. So this is your 4 ohm, this is your 2 ampere, and this is your 4 ohm again. There this current I will consider I2. So what is I2? Who can tell me? So for this one, when 2 ampere current is acting alone, the current through the 4 ohm resistance I am calling it I2. So what is the value for I2? Anyone? It's very simple. Exactly, it's 1 ampere. Thanks for sharing your answer. So this is 2 ampere. It is now divided in 2 branches, and these 2 branches are having equal resistance 4 and 4, so equally divided. So I2 is simply half of that, 2 by 2, that is your 1 ampere. So I2 is 1 ampere, I1 is 3 ampere. So total current I, that will be simply I1 plus I2 according to superposition principle, addition of these individual currents. So it is 3 plus 1 equals to 4 ampere. So you can see that one problem can be solved in different way. So I can solve in many ways. Okay, even you can solve it using super mesh analysis. That also you can do. Okay, loop analysis or mesh analysis. Here it should be super mesh analysis. Okay, that I am not discussing right now. I need to consider a few more problems. So this is the next problem. Right? So can you find V naught for this problem? So what is V naught? Okay, any idea how to solve this problem? So what approach you will take? Which will be the good one? Anybody? Anybody can suggest one method to solve this problem? So here you can see that there is only one single node. So node analysis is not a bad idea because you are having one single node. So this is suppose V1. Okay. So this node potential is V1. Now here what you can do, we can use KCL at this node. We can apply KCL. So this is your incoming current, 60 milliampere. Okay. And this is outgoing current, that is your IB. And this side current, this side voltage is there and current, all the things. Okay. So what you can do? So this 60 ampere current, milliampere, 16 to the power minus 3 I will consider, that is ampere, and that is equals to this IB is nothing but V1 by 100 is it okay, plus this outgoing current, it will be V1 minus V0 upon 250. Is it correct? So this thing, last thing I have considered here. So this network, the right side, you can rewrite in this way, then you can visualize it better way. This is plus, this is minus, and this one. So this I can do. Just what we are doing, so we can interchange these two positions because they are connected in series. If they are connected in series, we can first consider resistance, then we can consider potential source. It is fine. There is no one. So this node potential is V1. This is your ground node. This is your 60 milliampere. This is your 100 ohm. And this resistance is 250 ohm. Now we can see that this is given 50 IB. This is your V0. So with respect to this 0 node, this node potential is V0. So what is the current to this one? Is V1 minus V0 upon 250. So are you convinced with these things? How we are getting this one? Okay. Now here what you will do? So this V1 and IB, they are related because V0 is also given in terms of IB. So why not that? I will consider these two. So what is V1? V1 is nothing but 100 times IB. The voltage drop across 100 ohm, the current through the 100 ohm is IB. So obviously V1 will be 100 times IB. Is it correct? And what is V0? V0 is given as 50 IB. This is given as V0 equals to 50 IB. So we can use these two. Then we can have one equation containing only IB. Can you solve for IB? Anyone can please? So 60 times 10 to the power minus 3, that is equals to, so V1 is 100 times IB, this is becoming IB only, plus this V1 is 100 times IB and V0 is 50 IB upon 250. So who can calculate for the IB? hope we can solve for IB. Please let me know. This is IB. This is 50 IB upon 250 means IB by 5. Anyone can respond? Can you please find IB? What is IB? So it will be this 5B, 5IB and IB is 6IB. 6 will cancel out. It's a 50 times, I think it is 50 milliampere. Am I correct? Is it 50 milliampere? Try to calculate with me. So as we are calculating here, you should also try to calculate. Then you will get the confidence to solve the problems. So can anyone please let me know whether this IB is 50 milliampere? Is it correct? So I am not getting any reply. Anyway, we can move. So this is 50. Now here I can replace this 50 milliampere. So it is a 50, that is millivolt. So it will be 25500 millivolt, and that means it is 2.5 volt. Am I correct? So V0 I am getting 2.5 volt. Is it correct? I hope it is correct. So you can check. So if circuit contains some dependent source, you need to understand which method you will be using. So this is a simple circuit. So as it is having a single node, we can go for node analysis. We can use other things. We can use source conversion again. So this right side voltage source resistance we can convert to current source, but be careful, there we can have control current source. Okay, so then we can consider, we can combine two current sources, and then at the end we can find out the current through the 100 ohm, and that current will be equated with IB. We will be getting one equation for IB. We can solve for IB. So I am leaving it to you. You will try to solve in different way. Okay. Now I will move to the next problem. Can you find the current I for this circuit? Small I, it is shown here. This one. Who can find? So this is one problem containing one dependent source, one independent current source, and 3 more resistances. So can you solve for this one? So which method will be using here? Can you go for node analysis? So if you go for node analysis, how many nodes you need to consider? tell me, if we go for node analysis, how many nodes we need to consider here? One could be return node, and we need to consider how many nodes? At least here and here. This could be considered one datum node, but we need to consider two potential V1 and V2. So along with this I, we will be having another two nodes. So total 3 variables will be there, and we need to solve it. Okay, so can you solve it? So here I will be considering different approach. So just see what I can do. So this current is I, the current through 28 ohm is I, this is dependent current source 2I. So if this is I, this dependent current source, its magnitude is depending on this current I, it is twice of that. So can you identify what is the current through this side, this 4 ohm resistance? Anyone? Can you find the current through the 4 ohm resistance? That will be in terms of some constant value or small I. Who can calculate? No, I am asking that what is the current through 4 ohm resistance? It is not 2I. How it is 2I? So this is current is coming 12 ampere. This current is leaving I. This current is leaving 2I. So rest will go this side. So obviously this current will be, total current is coming 12. Out of this I plus 2I is 3I is going away. So rest will go through this 4 ohm. So 12 minus 3I is correct, exactly correct. So this is 12 minus 3I, perfect. Now next question, what is the current through this 8 ohm resistance? Can you calculate what is the current through this 8 ohm resistance? Anyone please? Note that this current is coming here, that is your 12 minus 3I. This current 2I is again added. So what will be this? 12 minus 3I plus 2I, exactly. So this is your 12 minus I, because this 12 minus 3I with this 2I is added. This 2I is added. This is your 12 minus 3I. So total thing is 12 minus I. Okay. So now you can see that in all the resistances we are having current, we are getting the current in terms of small I, that is fine. So why not we'll try to apply KVL through that loop where resistances are there. Okay, this is very interesting. So what I am saying that we can, so this thing, so you can see that this resistance and this resistance, if I consider this is a loop, I'll start with 28 ohm, then I'll go through 4 ohm, then I'll go through 8 ohm, then again I'll come back to this point. So I can consider one loop here. There I can apply KVL. Okay. So you should note that KVL is applicable to any loop. Okay. And you should try to avoid a loop containing current source, because voltage across the current source is not known. Then you have to take a variable. Rather, what I can do, I can consider this loop, this 28 ohm, 4 ohm and 8 ohm, this loop, there I try to apply KVL. Okay. So now you can see that, so what is the potential across these things? So current flowing downward, so this is plus, this is minus I am considering. This is the potential across this 28 ohm, 28 into I. And the current is flowing this side, I will consider this is plus, this is minus. That 4 ohm resistance multiplied with 12 minus 3I, that is the current. And this is the potential drop across this 8 ohm, 8 times the corresponding current 12 minus I. Now can I apply KVL? Be careful here. So minus plus I will consider positive. Okay, I am considering positive. So the voltage drop across this 28 ohm is 28 into I1 or a small I. Is it okay? This is the voltage drop across this 20 ohm resistance. Then I will consider this 4 ohm. But so if I move in clockwise manner, minus plus is positive, plus minus should be considered negative. So I will consider negative sign. Then I will multiply resistance into current. Resistance is 4 and current is 12 minus 3I. Okay. Then again, this is your plus and minus. Again negative. The resistance is 8. Okay. And what is the current? Corresponding current that I need to multiply. That current is 12 minus I. And that should be equals to 0. So is it clear to everybody? Am I clear how we have made this KVL equation? That is very important. So I am considering one loop containing those resistances, 28 ohm resistance, 4 ohm resistance and 8 ohm resistance. That loop I am considering. I am not considering other loops, only one loop. There I will apply KVL. Is it clear to all of you? Please write yes if you can follow me, and if you have some doubt, please share with your doubt. Share your doubt. Is it okay? Okay. So can you simplify this one? This is 28I. This is your plus 12I. This is your minus 8 is plus 8I, and that is equals to, so 4 and 12 is 48, and this is 8 into 12 is 96. Okay. So this one is 40 plus 8, 48I, and right side you can see that it's 48. It is 96. I think it is 48 times 3, because it's 48 into 2. Is it okay? So this 48, 40 will cancel out. So small I is 3 ampere. It's absolutely correct. It's good. So this kind of problem could be interesting when the circuit will have some dependent source. Be careful how to handle it. And if there is current source, try to avoid to use KVL through the current source, because across the current source you don't know how much voltage will develop. Okay, so try to choose one loop containing only resistances if possible. So that kind of concept is called super mesh. So basically we are considering here it is super mesh concept. One bigger mesh containing only resistances or the voltage sources, that will be good for us, that we will consider, and we will write KVL equation and we will solve for it. Okay, I think it is clear to you. Now this is the next problem. Can you solve this problem? What is the current I? Here again, can you identify which method will be good for this problem? Suppose if I allow you to choose any method, anybody can suggest. So before solving this one, please let me know which method you are going to use. Node analysis, mesh analysis, or any other things. No idea? Anybody? You can use source conversion or source transformation. Okay. So I can tell you that, so if you want to use source conversion, then this one, so this 4 kilo ohm and 15 volt, that you need to modify first to current source and resistance, and that current source, this current source, we need to add it up. So be careful about the sign. So current source will be directed to this side. Okay, and then those current source we can combine. Then again we need to multiply the resistance to get voltage source, and this one we can modify to voltage source. Then you will be getting only one voltage source, one resistance this side. Then again you can convert it to current source. Then at the end, current divider you can use, and you can find out the current small I. Okay, that could be the strategy. And second option I am giving you, can you use, because this circuit is containing 3 sources, independent sources, 2 current source and 1 voltage source. If circuit contains more number of current source, it is much better to use superposition principle. Okay, you can use superposition principle to solve this problem. So just I am giving you some idea, you will try to solve it. So only 30 kilo ohm is acting alone. 30 milliampere is acting alone. So can you see the circuit, how it look like? I am going to use the superposition principle. This source is acting alone, that is your 30 milliampere. This resistance is there, so that current source I have removed. So current source I am not considering. This is only 4 ohm. This voltage source is also shorted. Then this resistance and this resistance. I need to find out this current. That current I will be considering I1, that is through 12K, and this is your 6K. This is 4 kilo ohm, okay, sorry, and this is your 2K. Okay, so anyone can please find out the I1. Who can find I1? I am just waiting for your response. Please share your answer. Can you find I1? That is the current through 12 kilo ohm resistance. For this circuit, when only 30 milliampere current source is acting alone, and we have removed 15 milliampere current source open circuit, and we have removed 15 volt source by short circuit. So how quickly we can solve it? So first you can note that these two we can combine for time being, though later we can modify it. So 12K and 6K. What is the parallel combination of these two? These two are parallelly combined. So 6 into 12 by 6 plus 12 is 18. So 6, 3 and 3, 4. So it's a 4K. Okay. This is a 4K. This is the 4K. Total is 8K. So what is the current in this side? That current first you can compute. Then that current will be divided among this 12K and 6K. So first so you can see that 30 milliampere current is coming here. Now this is the branch, this side branch is 2K, this side branch is 4K, and this 4K, 8K. Okay, so how to find these things? So this current I am considering this is I or I dash, I prime. I prime is simply, how much it is? It is a current divided 2 upon 2 plus 4 plus 4 is 10 upon 30 in multiple 30 means 6 ampere. 6 ampere is here. This is your 6 ampere. Out of 6 ampere, the through 12K, it's again current divided. The opposite resistance 6, this is 6 milliampere, okay? Be careful. 6 upon 6 plus 12 times total current is 6. So 6 by 18 means 1 upon 3 into 6 is 2 milliampere. It's perfect. Those who have got 2 milliampere, it is perfect. So it is, remember it is in milliampere, not in ampere. Okay. Very similarly, when this 15 ampere is working alone. So can I consider this thing? When 15 milliampere is acting alone, so what is the circuit? So this is there. This is 15 milliampere. Okay. And then I will consider this current source, I will remove it. This resistance I need to consider, it's okay. This is 4K, this is 2K, the current source I have removed, this voltage source I have removed by short circuit, then this is the resistance and this is the resistance. This is your 12K, this is your 6K. You need to find out again this current, and that is suppose I2. Exactly very similar manner you can find out the current I2. So what is I2? Anybody? So I2 is again 2 milliampere. So Hertz is saying that it is 2 milliampere. I think it looks correct. So you will check. Okay. Now last one. This 15 volt source is acting alone. Okay. So this 15 volt source is acting alone. That time how can you solve these things, this problem? So now 15 volt source is acting alone. Okay. So what is the circuit? Just I am drawing the circuit. So this resistance is there, current source I have removed, this resistance will be there, this source will be there, and that current source I have removed, this resistance and the last resistance. This is your 12K, that is your 6K. So this current is I3, this is your 2K, this is your 4K. Can you find I3? So remember, this is your 15 volt source. Okay. Can you find I3? Who can find? So be careful about the sign. This is the current flow, it should be, because this point terminal, this side current should flow. So first you can find out the current here in this main branch. Okay. So he is saying that I3 is, I think you are calling it 0.5, it should be minus 0.5, because opposite side, minus 0.5 milliampere. Okay. So if you can get these three, so what is I? I total is I1 plus I2 plus I3. That will be a 2 plus 2 minus 0.5. It is your 3.5 milliampere. Okay. I hope. Yeah. So you can see that we are not going to write any equations in this circuit. Though it is complicated, three sources are there. If you go for node analysis, at least 2 node equation you have to find out, 2 variable. And if you go for mesh, there are lots of meshes. 1, 2, 3, 4. 4 meshes. You need to consider 4 meshes, then you need to consider some super mesh concept, then only you will be able to solve it. Okay? So in this problem, superposition principle could be one interesting one, and source conversion is also good. Okay? Now we'll move forward. For this circuit, can you find Thevenin voltage and Thevenin resistance? RT and VOC. VOC means Thevenin voltage. So this is a problem regarding Thevenin voltage, Thevenin parameters, Thevenin voltage and Thevenin resistance. So what is VOC? VOC is nothing but open circuit voltage, Thevenin voltage at the nodes. So this node is given. So this node, I can call it A and A prime. There we need to find out this potential VOC. Now how can you find VOC? Which method you will use? So VTH, he is saying 2 volt. Okay. So which method you have used? Node, source conversion. What is that? I think source conversion could be one easiest one. It's a very simple one. So if we want to find out VOC, that thing only we are going for. So we will keep everything, we will try to find out output, open circuit output voltage. So this current source resistance, that we can convert it to voltage source resistance. Remember, this side is plus, this is minus. And resistance I can consider here. This resistance is 6 ohm and this is your 6 into 1. So I need to multiply current into resistance. So 1 into 6 is 6 volt. Okay, then this is your 6 ohm and here it is a voltage source plus minus, it's a 12 volt, then this is your resistance 6 ohm. We need to find out this potential VOC. Good. So you can see that, so this 12 volt now and 6 volt we can combine, they are in opposite in nature polarity. So effective is 12 is stronger one, 12 minus 6 is 6. So effective direction will be, this is a plus, this is minus, because this is plus 1. So 12 minus 6 is 6 volt effective, and then this 6 ohm I can combine to one resistance, that is your 12 ohm, and then it's 6 ohm is here. And here we need to find out VOC, and that is your very easy. VOC is this self resistance 6 ohm by total 6 plus 12 times 6. I am quickly solving these values using voltage potential divider concept. So if you have some doubt on potential divider, how I am doing it quickly, please go through my previous videos. Okay, if anybody is having any confusion, please do go through these things later on. So this is 1 by 3. So yeah, it is, how much it is? It's a 2 volt. Good. So VOC is 2 volt, VTH is 2 volt. And what is the RT? RT means you need to remove all the independent sources. Voltage source should be replaced by 0 potential, means short circuit. This is your resistance. This is your resistance. I have replaced this part is shorted, and this part we need to remove it. So I have only this one. This is 6 ohm, this is 6 ohm, and this is 6 ohm. Now from this terminal we need to look we need to find out the resistance looking from this terminal. So if you see that if we go from this side, then we are having these two branches, this branch and this branch. So these two I can combine. 6 plus 6 is 12 ohm. Then at the end, this 12 and 6, they are parallelly connected. So RT will be 12 parallel 6, that is your 4 ohm. That we have already computed. It is 18, that is your 4 ohm. Good, very good. So VOC is your 2 volt and RT equals to 4 ohm. Correct. So this is easy problem. Let me consider one problem here. Okay. So can you find Norton equivalent circuit, ISC and RT? Circuit is containing dependent source. So I am asking one problem. So this thing I am giving it to you. Okay. So one more problem I will be considering because we are running after time. It's more than 1 hour. Okay. So you will try to find its answer. What is ISC and what is RT? And you will let me know in the comment section later once you will be able to solve it. Okay. So this is not an equivalent circuit containing one dependent source. So be careful about dependent source. So ISC is open or short circuit current. Remember, it's a short circuit current is ISC. SC for short circuit, and RT is the Thevenin resistance or Norton resistance looking from this node. Okay, so this thing you will calculate, let me know, and so one more similar problem I am calculating for you. Okay. So this is the problem. Can you solve it? Again, short circuit current and Thevenin resistance or Norton resistance we need to find out for this problem. Okay, so we will consider this thing one by one. Okay, so I have one idea that I have shared with my students, that if circuit contains some dependent source, you can take one method to find all the Thevenin and Norton simultaneously. Okay, so this circuit is given. Okay, to find out the Norton equivalent circuit, first you can find out Thevenin. That's also fine. You can find Thevenin, B.Tech and RT or RTH. Then you can easily convert it to I Norton and RTH. So you can use source conversion. So this will be your B.Tech by RTH and this is the same as RTH. Okay. So this I Norton is same as, so I think it is not visible, fine. So Thevenin and Norton you can find out, right? Now here first in traditional way we will try to find out ISC. Can you find ISC? So what is the problem with these things? Okay, so this is not an easy problem. Be careful about the polarity. So I need to make it sorted. Okay, and be careful. We need to assign a current downward. That current is ISC. Because this is the current flow. And this is the current flow here, ISC. The left to right, that is the important thing. Upward, downward is not important. Important is current flow is from left to right. Okay. This is your 3 ohm. This is your 6 ohm. This node potential is given. This is plus. This is written at, it is VA. Then this current source value is 1.33 VA. Okay. Now can you tell me what is the current through this side? Okay. I am discussing this thing, I will be discussing more problem. So one session may not be sufficient. We will solve similar kind of problem containing dependent sources to find Thevenin equivalent or Norton equivalent. Okay. So this is plus minus VA. Now can you find out this current? Anybody? And remember that this is a 24 volt. Or directly also you can find out VA. Anybody can answer. What is small I in the circuit? That's okay. But ISC is not known. ISC is not known. We need to find out ISC. Okay. So you can see that this is one single loop. So this loop I can consider. So there is no drop as it's short circuit. There is no voltage drop. So potential across this one. This is important. Potential across this one is your 0 volt. Am I correct? Because it is short circuit. Why? Because this end is shorted. If this is shorted, between these 2 points, there is no potential gap. Potential difference is 0. So I can consider this loop. So current will be simply this 24 volt by total resistance in this loop. The loop is 3 plus 6 is 9. Okay, means 8 by 3 ampere. Now what is the potential? VA. Can you find VA? Now next question is what is VA? So VA is nothing but potential across these 2 ends, that is same as potential across this 6 volt, because there is no more voltage drop. So if it is 6 ohm, so across 6 ohm what is the current here? So same current I is going to this side. Okay. So VA, check the polarity. VA will be the potential, this plus minus. So this is your, but current is given on opposite side. So it is minus I times 6. Okay. I think it is minus, so how much it is? Minus I times 6, I is 8 by 3, so minus 16 volt. Is it right? Now you can find out ISC, as you said that ISC. VA is 16 volt, fine, perfect, but you should keep the sign negative minus sign, because the polarity is given, this is plus, this is minus. Be careful about polarity. Exactly correct. So what is ISC? So this current, so ISC plus I equals to this current. So this current is ISC, this current is I, this current is leaving 1.33 VA. So can I write ISC equals to 1.33 VA minus I? So this will be 1.33 times minus 16, and minus I is 8 by 3. So this could be considered for 4 by 3. No? It is a 4 by 3. So 4 into 6 minus 64 by 3, it is minus 8 by 3. It's minus 72 by 3. Okay. So minus 72 by 3 equals to minus 24 ampere. So ISC is minus 24 ampere. Is it okay? And RT, I think we are running out of time. We need to leave right now. RT we will be discussing in the next class. How to find RT. Okay. So please keep watching. I will be discussing more problem. This week again I can take one more lectures to discuss more problem. Is it going to be useful to you? So RT you will try to calculate and let me know if you can find out RT. No. This is 8 by 3 ampere is not short circuit current, because short circuit is okay, it can follow any current, but this is a dependent source, this is a current source. This will generate 1.33 VA, that is sure. So this I and this ISC will give you this 1.33 VA. So ISC is not same as minus I. Okay. So RT will calculate. So you have got 9 ohm, we'll check later. So you can recheck. So answer could be a little bit different. Okay. And if you can find other answers later, please let me know. Okay. You share me in the comments. So is it going to be useful to all of you? I think it is difficult, it's not easy whenever the circuit is containing some dependent sources. So I will discuss more problem with this kind of circuits. Okay, I will show you that how to find Thevenin resistance or Norton resistance very quickly, very easily. Okay, so I will discuss that problem in the next class. Please keep watching.